Hi there, it's Candace. We recorded this AI webinar that you're about to watch a few weeks ago, before OpenAI announced their exciting new features like custom GPT agents and the Assistance API. Our team's been busy building their own GPTs, from Ferment GPT to your custom product pair. Check them out on LinkedIn. We still think it's valuable to share how we built our custom chatbot using LangChain and Pinecone. We hope you'll enjoy this webinar. Hi, everyone. Welcome to a conversation with Focus Labs. Focus Labs is a consultancy that specializes in custom software development on top of legacy applications. Today, we're going to be talking about AI tools. So, we built an AI knowledge base, an internal tool for us to use. And what we're going to walk through today is how we built it, why we built it, and what we learned along the way. So with me, I have Kaylin and Sarah, who are developers extraordinaire at Focus Labs, and they're going to be digging into kind of the tech stack and everything that we put together. To start us off in the conversation, I want to start with why did we build an AI knowledge base, and what were we trying to learn?
Sure, I can start us off. Um, I think first, it's a lot of AI tooling is just starting to come out in the software industry, and we're like, well, great. Now, how do we use it? So part of it's just like playing around with it, see what it's capable of. How can we use this in our everyday lives for creating software? And then another thing that we wanted to look at is often as consultants, we'll come into a company and we'll need a lot of information to get a project started or during the middle of a project. A lot of subject matter experts just are so busy, it's hard to get time on their calendar. So it's like, what if we took some documentation that the company has, maybe even an interview with a subject matter expert, and we load it up to one of these large language models and have it be able to answer questions that we have about the company. Like, would that help us efficiently do our jobs? And would it free up time for subject matter experts and things like that? So that's where we started when we started building this knowledge base.
Yeah, I love that. What you're really highlighting, Sarah, is what a lot of AI tools and kind of what AI is enabling for everyone, which is efficiency. Efficiency is really the unlock that a ton of AI tools are providing. And so what we were looking at and what we were trying to test is, can we build something that will make it easier for people to find the information they need so that they can have more time working on critical tasks, which for our teams is building working software. So with that, so we have like efficiency as the unlock that we're trying to figure out. Um, there was also a lot of just understanding like the AI tech stack and tooling. So, you know, it seems like a long ago now. If you check out the tool that we have linked here, our demo, it's a lot more polished, today than it was when we first started, both from an accuracy perspective and in terms of usability and a number of other factors. And so, I want to dig into how we got the tool to the place that it's in today. And so, let's talk about some of the challenges that we faced. Kaylin, Sarah, what would you say are some of the biggest challenges that we came across when we were, seeing if we could kind of like unlock efficiency, but also just trying to dive into the AI tech stack?
Yeah. So I think our biggest challenge was accuracy. Going a little bit higher level of what we built, we were really inspired by ChatGPT and ChatGPT's ability to synthesize and summarize information in a way that makes sense to you yourself. And so we wanted to follow that pattern. We wanted to create a custom domain specific chatbot. So think um, the capabilities of ChatGPT, but with information that is not available to everybody on the internet, just available to you, your company, your legacy system, your SME knowledge, right? That Sarah was referring to. And so we started off at the very beginning, just going through a very basic tutorial on OpenAI's website. It was very quick to spin it up, following the step-by-step instructions, but it was very apparent that the accuracy was not great. It quickly ran into hallucinations or answers that were just not correct. It would try to provide answers it thought you wanted to hear instead of saying, I don't know, or please contact Focus Labs for more information. So I think our first big step in unlocking accuracy or unlocking a really helpful type of application was figuring out a good architecture and a good tech stack. Um,
Yeah, and I know one example that you often bring up, Kaylin, of, just how much our tool was hallucinating in the beginning is that, if you asked it like, "Hey, where are Focus Labs offices?" and, it'd come back with things like Hawaii. And while we all, dream of eating poke on a beach in Hawaii, that's not where our offices are.
Nope. We're in Denver and Chicago. So
yeah. It was
um,
especially puzzling because we knew the information that we fed into this, custom knowledge base, and we knew that the information was in there. And so we had to figure out different tips and tricks to get it to find that one sentence on that one page and feed it to you in a way that made sense.
Yeah. So accuracy is, one of the problems for sure. So let's like dig into that a little bit more. You're starting to talk through the type of data that we fed into it. I know we went through different processes to cleanse the data. So like let's dive a little bit deeper. And can you both tell me more about how did we experiment to get to the accuracy that we have today?
Yes.
you
Oh,
want
so Uh, what I'd love to start off with is just talking through like what we ended up building and the core components of the architecture. I think that will really facilitate this conversation in a way that will make sense. So, Candace, I appreciate you pulling up this
Oh, I got
lovely,
it. Banner that
lovely
we're walking
picture.
in.
Yeah, I mean, pictures are worth 1,000 words, and it'll help us facilitate this conversation, like I said. So at a high level, our knowledge base is split into two pieces, the ingestion flow and the query flow. So the orange outline box and the purple outline box here on the screen. The ingestion flow is where you take the data and then you import it into your application. So you literally load the data. You cleanse it, then you split it into smaller pieces. So think taking a PDF and putting it into words or sentences. And then you take those words and you make them readable for the computer to understand the meaning behind them. So this process is called vector embedding. And the vector embedding is a literal mathematical string or mathematical list of numbers that capture what is the meaning behind certain words. And so we use a model to do this embedding for us. We don't do it ourselves. Thankfully, we're able to use the model for that. And so then we take these vector embeddings, these mathematical representations, and then we store them in a vector database. So then in the future, when we want to query the information or we want to have a user come in, we can retrieve that information. So that's the query flow, is the user comes in and it, uh, they can ask a question like, who is the CEO of Focus Labs? And so you will go back, or the application will go and search the vector database for words that have similar meaning to CEO and Focus Labs. And so if there's a PDF out there about the org chart that contains the phrase Austin is the CEO of Focus Labs, it'll find it and bring it back to the user. And we're able to use this LangChain agent to help facilitate when and how to call that vector database, because remember, the vector database is all just math. So it's not something that we humans understand, it's something the computer understands. So we need a little bit of help to do that. And we're able to leverage GPT 3.5 or the actual LLM in order to take the database information and the original user's question and create a response that makes sense in natural language. So that way you're not just reading the raw results from the database, you're reading something in a conversation format. Um, so that's really cool. So these are like the core tenets of our architecture. And I think our first unlock that we want to talk about is just the technology stack. Uh,
Mhm. Yeah, like initially when this project was put in front of like Kaylin and I, Luke, our CTO, had gone through and did one of those tutorials and tried to load a bunch of data up to the vector database, and it would answer some questions, right? But we're like, okay, we need to iterate on this. We need to improve it and figure out like what's out there, what can we use. I think I came across Llama Index initially, and I was like, hey, this tool, what it does is it'll go and parse all the data, chunk it, put it in a nicely embedded format so it can be put into the vector database for us. We don't have to worry about any of that. It'll do it. And that is where we started. It also had its own like chat tool, which we initially started with, but I think that we decided to go a different direction later. I can't remember why, but um, so the
Yeah.
first pass, we loaded that data, and but then it was like still not quite right. So we needed to do some more investigation on like, all right, what do we need to do to this data to improve the answers that we're getting?
So if I were to, if we look at like accuracy as the challenge that we were facing and the problem that we were trying to solve, and one of the first things we reached for, you look at this architecture diagram, was the tooling. So there was like some hand rolling of tools we tried. Then we went to see what was openly available for us to use. We found Llama Index, started exploring that. That helped us gain some increase in accuracy, but didn't get us quite to where we wanted. And so I know there's more that we did with regards to the data, how we organized it, cleansed it. Um, so let's hear a little bit more about that.
It kind
yeah,
of
so oh, go ahead.
I was saying this whole project's kind of like a research project because we did these kind of bumps and then we'd be like, okay, let's go search the internet for a while, see what we can learn, and then come back and try to implement. So it's cool.
Yeah, I think that's a really good point. I'm gonna take us on a little bit of a rabbit trail for a moment, but another big challenge that we had while we were trying to unlock this accuracy was lack of resources on the internet. It was really, uh unsettling, I guess, to go to Stack Overflow and be like, "There's nothing here." We find our question that we're asking, and there's no responses. And so on one hand, it was really cool to be on the bleeding edge of technology, like, that so cool, but on the other hand, we were on the bleeding edge of technology and there were a lack of resources, and so we really had to go back and understand like best practices, and we had to use our own expertise to figure out how to apply those best practices for our use case. And we were able to leverage a lot of our existing software engineering experience and consulting expertise to figure that out. um, but it's a really cool field.
Yeah,
Yeah.
I remember we had a lot of conversations, in stand up, in our planning meetings when we'd be looking at the backlog of our work. It'd be like, oh man, like this is the next thing that we want to do, but we don't even know what we don't know. We don't know where to get started. We searched for some resources, no answers to our questions. And, it really feels like explorers in an uncharted territory, or, like lost in the woods with no cell phone reception, no map, no compass. And you're like, which way do I go? And so there's definitely, I know, a lot of that for the team and trying to um, carve a path forward. But a lot of what we did, like a lot of what both like Kayla and Sarah, what you're both explaining is in order to kind of move forward and build that path is we did a lot of small experiments, like a series of experiments to figure out this worked, this didn't. Maybe this piece worked a little bit. Let's mix it with this piece to like take those small steps forward.
Yeah, I
Yeah.
think that's a great place to like start about talking about like we'd make changes, but then we'd be like, okay, what was effective? Or we make too many changes. So it's like once we were like, okay, what if we strip emojis out of something like Notion? Was that going to improve the accuracy? We came up with like a set of questions that we would always ask it and see if tweaking one thing would improve the answers that the knowledge base gave us.
Yeah. I think that's one of my proudest accomplishments on this project actually, is figuring out how to test and evaluate our tweaks, our solutions. Like, how do we know if this is actually accurate? How do we know that we're not just, forgetting or we had a bad day or something like that? And what really helped us is understanding that this AI application kind of behaves like a cake. We can't just tweak one, like ingredient, like adding more salt and then measure the cake halfway through the process. Like that's just it, you kind of are left hanging. You're like, is this a good cake batter? I don't know. Like you can't really test cake batter. And so going through the whole process allowed us to measure the outcomes, and so then we were able to evaluate, like, is this cake better than this cake if we added a little bit of salt? So viewing this application from that holistic perspective really helped us to do testing because we're used to, like, unit testing in
Mhm.
our other software applications. Like, we're really, really intentional about, like, test-driven development, and we're really excited about that, and you can look at a bunch of our other resources, if you're really curious about that. We have a lot of opinions on them. We'd love to talk to you about it. But anyways, we really unlocked this concept. So what Sarah was saying of like we ran these experiments where we were able to come up with a list of questions that were a standard list of questions. And we would walk through like kind of the scientific method. We'd have a hypothesis, we'd have a one variable that we would change, and then we would ask the same set of questions, and then we would judge the accuracy at the end. And so we would be able to have this documentation of what did improve, what didn't improve. And by having a hypothesis, it really forced us to understand, why are we doing this? What are we hoping to accomplish? And what did we learn from this experiment?
Yeah. So if we go back to, these challenges and these small experiments that we're doing, were primarily for continuing to improve the accuracy of the AI knowledge base. And so we reached for tools like Llama Index. We came up with our own set of questions that we used, keeping the questions the same so that we could iterate and see where we were getting an increase in accuracy in the responses from our chatbot. And then I also know we talked a lot about prompt engineering as something that we kind of experimented with. And so, can you both tell me like a little bit more about how did prompt engineering fit into improving accuracy for the knowledge base?
Sure. So prompt engineering is a way of giving instructions to a large language model on how it's going to answer questions. The way you write a prompt can change the accuracy of the responses it gives. There's some really strange things, like just saying, hey, think really hard about this before you answer will improve the accuracy of the results, which kind of breaks my brain a little bit when I think about it. So I'm just like, I don't exactly know how that works, but it does. So doing things like that, giving it examples of how you want it to answer questions, telling it to say, hey, I don't know the answer when it's not sure. Those were things like paths we went down.
Yeah,
Yes.
absolutely. I love that you said that because that's like you said about telling it to say I don't know instead of making stuff up was how we combated hallucinations. Like it
Mhm.
mostly like it was very effective. We were able to get it to say I don't know based on a prompt. And that was like such a big win. But it like definitely blew our minds. We had to think more like linguists and less like software engineers. We had to understand how we were saying things instead of just viewing them as bytes in a stream. We had to think about the meaning of the words.
Yeah, there was one particular one question we had, which is, what are the Focus Labs values? And we know when we ask that question, we're asking about core values. It interpreted that differently. It was like more like, what is Focus Labs value in general, rather than spitting out the core values. That was like one we had a heck of a time getting it to get correct.
I remember seeing the responses to that question over and over. It would pull in anything that seemed valuable from our web pages. But yeah, go ahead. Sorry, I didn't mean to cut you off.
Oh no, it's fine. I think once we tweaked that question and we were like, well, what are the Focus Labs core values? It would spit out the correct ones at that point. So it's just like little things like that can get huge differences in results.
Yeah. Yeah, I think you and we did an experiment early on when we were cleansing the data that really hammered this point home. We were trying to normalize the data to be all lowercase. We were like, oh, if it's all uniform and normalized, it should be happier and we should get a more accurate result. So that's what our hypothesis was. We ran the experiment and our accuracy decreased like enormously. And you and I looked at it and were like, what? Data's more normalized. That doesn't make sense. Until we realized that LLMs act more almost like human brains than they do like a function or a method. You have to think like a linguist and less like a software engineer, which is like such a hard switch.
Mhm.
Another piece, you talk about thinking like humans, or thinking like a linguist, and each of us brings into conversations our, perspectives or backgrounds. One of the features that our knowledge base has is different personas. So you can select who you are, and that will also change the responses. So can you explain a little bit more, like what's happening on the back end to change those responses? So I think like one example is if we talk about the word benefits, if I'm asking that as a prospective employee, I'm expecting to hear about, like 401k and healthcare and vacation and, standard things that fall into like a benefits package. But if I'm a prospective client and I ask about the benefit, I might be asking about the benefit of working with Focus Labs. And so this goes back to like the nuance of words. But I'd like to lift the hood and talk about like technically what's happening to help like shape some of those responses that we were getting.
Sarah, do you want to go first? You want
Oh,
me to answer?
you can go.
Um, Prompt engineering is the short answer. Um, Prompt engineering is really powerful. Don't estimate it. That's your best practice for the day. But we were able to generate a prompt dynamically. So through the architecture of having an endpoint, we have two fields in that body of your request, which is the actual question and then the role that the user had. And we were able to, just plug that in through some Python arguments into our prompts. And the LLM is smart enough to understand that and bring the appropriate personality or perspective back to the user. So it's a pretty simple implementation, to be 100% honest. Uh, but it's a really powerful one.
Yeah. I think all we say is like, answer this for a prospective employee, or you're answering questions for a prospective employee, something along those lines. And it's pretty simple. So.
Cool. So to maybe kind of summarize some of where where we are today. So accuracy is one of the biggest challenges that we were talking through. And the things that we faced in kind of tackling accuracy was like one, just like the ambiguity of even being able to solve that problem, not finding like the resources, the help, or um, just these things hadn't yet been solved as we were starting to dive into them. We experimented with tooling, things like Llama Index. We ran our own small experiments in the form of questions. We explored prompt engineering to all help us drive at accuracy. Is there anything we missed? Is that pretty good
Um,
summary of kind of like what we tackled?
yeah, I would also like put in there like every time we tried to add like a new tool, it would always kind of like accuracy would go down a little bit. There's always 2 steps forward, 1 step back. So it's like realizing that sometimes and you had to like say, okay, is this new tool suited for the job we have, or do we just not know how to use it properly yet? So usually it was the latter. Um, there were a few where we're like, oh, this one's just not for us. It's fine. But yeah, I think it was like it's just like iterating on on that concept, I guess.
Yeah. I think the one other big unlock moment that we had was when we used the LangChain agent
Mhm.
instead of Llama Index or a um, any other architecture. So a LangChain agent is you can think of it like a brain that makes a decision on whether or not it needs to even use a tool. And what it unlocks is like robust question answering. So it was able then to answer questions like, "How are you?" or "How do you feel today?" or those types of questions, or like, "Write me a poem about Focus Labs." The types of things that you don't need to query the vector database for, that you would kind of, or like chat memory, like being able to recall past or refer back to a question that was just asked of like, "Tell me more about that." All of those features were more accurate when we use the LangChain agent. And so the agent, yeah, from a technical perspective, it's a brain that figures out and uses an LLM to make decisions of whether or not it needs to use a tool. And so once we made the switch from Llama Index to LangChain agents, it was really cool. We were actually able to see chat memory work. We were able to get more accurate results, and we were able to have a much more like robust question answering. And it still says I don't know instead of hallucinating, which is fantastic.
Yeah. Something else like going along those lines I didn't realize was like when you talk to these knowledge bases or chatbots or whatever you want to call them, that it's not just one LLM, it's like multiple. So like it's like you have the agent who decides if I need to go talk to the other chatbot, and then it comes back and it tries to synthesize what the other LLM said, and it's just interesting like how that whole network of things works together. So
Mhm. They're a lot more powerful when you chain them up together,
mhm.
for sure.
Well, this has been a really awesome conversation. Looking back at like where we started on, we just want to build an AI tool to how we got to the demo that we have today, which is like pretty accurate, can give you some really cool insights and info about Focus Labs. We want to do more of these to share what we've learned, what we are continuing to learn. And so, like, comment, let us know what else you'd like to hear from us. And in the meantime, if you're looking to learn more about Focus Labs or what we can do with AI, you can check out our website, focuslabs.io. And we have an AI page if you want to, link to the demo that we have, learn more about our process. Um, and that's about it. Thank
Yeah.
you for joining and watching.
Mhm.
Thanks for listening.